So vertical stretch, again, we're kind of working with the y values and thinking kind of up and down of our graph. And really this will be a stretch or compression. So let's just play with the numbers and see how these come about. So with the table, if I'm looking at this 2 times g of x, this is telling me to take each of my g of x values and multiply by 2. So where I have -2, I'm going to have -2 times 2, which is -4. 2 times 6, 12. 2 times 6, 12. 2 times 0, 0. -2 times 2, -4. So let's see how this comes through on our graph. So we have our graph here. And what I'll do is just focus on those key coordinates first. So I'll have x equals -2 and y of -4. So I'll put me down here. I'll have 0, 12 and 4, 12 and 7, 0. So I still have that same coordinate there. And then 8, -4. And then I'm also going to have these other coordinates out here. So I'm just going to connect these. To get our new transformed graph. Okay, so what this did, if we think in terms of, well, you could just think about the height of the graph even. Like we went from +6 to -2, so you could kind of think about our original range of the graph. And now what's happening is we're going from -4 to +12. Our graph stretched. It's stretched out vertically. So along the y-axis, it hasn't changed horizontally at all. Our x values are exactly the same, but it's every y coordinate that we had, we doubled. So you can think of it as a doubling of distance too from the x-axis. So like if I think about this coordinate 2, 6, originally it had this distance of 6 from the x-axis. After this transformation, we've doubled that distance away. It's now a distance of 12. And that's what we did to every single coordinate in this function. Like here we have this 5, 4, and now it's 5, 8. So all of these vertical distances doubled. And same thing in the negative direction, where we have this distance of -2 over here, now it's -4. The points that don't change are the ones that are on the x-axis, because if you're on the x-axis, there's no distance away from the x-axis, so there's no distance to double. But absolutely everything else gets a doubled distance. So what we're seeing here is a vertical stretch by 2. So that's your factor of the stretch, is a 2. Let's see what happens when we do 1/2 times g of x. So what I'm going to do is take the original g of x values and multiply them by 1/2. So 1/2 times a -2 is a -1. 1/2 times 6, 3, 3. 1/2 times 0 is 0. 1/2 times -2, -1. So what we're seeing for our new coordinates now are those distances we originally had away from the x-axis are all cut in half now. And then if it's on the x-axis, it just stays on the x-axis. So this makes a vertical compression. It's like we squished it towards the x-axis. This. So where we had, let's say we look at that 2, 6 again, where we had this distance of 6 before, now we've compressed it to a distance of 3. So here we're seeing a compression, vertical compression. By 1/2. So with these vertical stretches and compressions, think about those vertical distances, and then it's either you're multiplying them up or compressing them down. So how the numbers appear, it's coming through as a number that's multiplying with our function outputs, so it's multiplying outside of our function notation. You'll see these absolute value symbols here where we'll talk about what happens when a is negative and what that will do, but it's kind of its own rule. So whatever a is, if it's negative or positive, just thinking about the number part of it, if the number is more than 1, so like this first case here, where it was this factor of 2, then what we'll have is a vertical stretch. If your factor is between 0 and 1, so like this will come through often as a fraction or a decimal. Now, but be careful, because there are fractions that are larger than 1. Like if our fraction was 3/2 times f of x, then it'll be a stretch. But any fraction that's between 0 and 1 will cause a compression. So it compresses by that factor. So let's talk about what happens if it's negative. Even if we could have had a number here too, but let's just say, no matter what if there's a negative right there? So what you would do is you'd go through that g of x row on the table, and you basically change the sign. So like, instead of -2, we'd have +2. Then we'll have -6, -6, 0, and then +2. So what we're doing is we're going through our y values and changing the sign. So where we had negative, now we'll have positive. Where we had positive, now we'll have negative. And what this is a reflection across the x-axis. So if there was a number in front, we'd do our stretch and compression as we just learned how to do. If a is negative, then what you would also have mixed in there is a reflection across the x-axis. And you can either stretch and then reflect, or reflect and then stretch. The order isn't too important there. So if you have a negative value, we reflect over the x-axis. Or you could think of this as y values change their sign. And that if your output was negative, it's now positive, and where your outputs were positive, they're now negative. But the x values stay totally the same, meaning where we have this coordinate 2, 6, 2 staying exactly the same, all that's changing is the y value changes sign. So, alright, let's get some practice here. So we have this original function, and we are going to graph these transformations. So 3 times g of x, just going to make a note that that's going to be a vertical stretch by 3. So I'm going to be tripling the distance away from the x-axis. So first thing I'm going to do is just get some key coordinates here. So I have this -6, 0. I have this 0, -6. I have this 3, -3, and 6, -3. So what I want to visualize is, okay, if I'm on the x-axis, that's going to stay exactly where it is. What I'm going to be doing is, where I have this vertical distance of 6 here, I'm going to triple that. So I'm going to need a long y-axis here in order to actually graph these points. And the same thing here, where I have this distance of 3, I'm going to need to triple that to get to 9. And then for 6, I'm going to need to see to 18, essentially. So with that, I'm going to have my y-axis have a scale of 2, and then my x-axis can stay the same. So with that, I'm going to graph my original points here. So I'm going to have my -6, 0. I'm going to have my 0, -6, So 2, 4, 6, 3, negative 3. So 1, 2, 3, and then that'll be negative 3 because of my scale of 2. So there's like 2, and then halfway will be 3. And then 6, negative 3. So there. So here I have my original function. It just looks a little different because of that change scale on the y-axis, but it's the same thing. Alright, vertical stretch of 3. So starting with that first coordinate, that stays put because it's on the x-axis. For 0, negative 6, I'm going to triple that distance. So I could just think in terms of there's 3 units. So times 3 would take me to 9. So I'm going to have this coordinate down here. But you could also think of that as what we did is we multiplied the y value by 3. So now I'm at negative 18. So same idea. Same thing here. So I'm at negative 3. So times 3, I'm going to be at negative 9. So go 2, 4, 6, 8, 9. And same thing over here. 2, 4, 6, 8, 9. So where I had this distance here, now it has tripled. And then I just need to connect the dots. So here we have this kind of curve and line and line. So we stretch that out by a factor of 3. This next one will be a compression. So vertical compress by 1/3. So here everything's going to be kind of shrinking towards the x-axis. So where I have this distance of 6 here, I'm going to divide that by 3. So I'll have a distance of 2. And where I have these distances of 3, divide that by 3, I'll have these distances of 1. And then if it's on the x-axis, it stays on the x-axis. So I'm going to change my scale back to just 1, 1, 1, 1, because we don't need to stretch as far on the y-axis. Okay, I'm just going to draw my original coordinates here so that we can visualize where we're starting. So here we have our piece of a circle, line, line. So that negative 6, 0 stays put. Where I have this 0, negative 6, I'm going to take that y value of negative 6 and divide it by 3. So I'll be at negative 2. Where I have a y value of negative 3, I'm now going to have a y value of negative 1. So with this, I'll have the curve. Let me try that again. Curve and line, line. So there's our compression by 1/3. All right, this next one, we can see we have a stretch. We're going to have a stretch by 2. We're also going to have a shift. And our rule of thumb is going to be to carry out the stretches and compressions first, and then shift at the end. So I'm going to have 2 pieces here. I'm going to first stretch by 2, vertical stretch, because we're also going to talk about a horizontal stretch. So I'm going to specify vertical stretch by 2, and then we'll end up vertical shift. So we're going to go up 3. Alright, with this vertical stretch, I'm just going to stretch out the y-axis, use that scale of 2 again, just in case any points try to go off the page. So here's our negative 6, 0, 0, negative 6, 3, negative 3, and 6, negative 3. So again, our original function, it just looks a little different because I changed the scale of the y-axis. So first thing I'm going to do, stretch by 2. So this coordinate stays the same, so I still have negative 6, 0. Where I have 0, negative 6, that's going to stretch by 2, so now I have 0, negative 12. Where I have 3, negative 3, it's going to stretch by 2, so now I have 3, negative 6. And same thing at 6, negative 3, now I'll have 6, negative 6. So I'm going to just draw this as a dotted line because we have another shift to do. But this can show the stage of what it would look like if we stretched it out by 2. And notice this is the same as the original function. It's just with our scale of 2, it looks like it's the same as with the scale of 1, and that's an effect of a stretch when we had already compressed our y-axis. Anyway, our last piece is to move up by 3. So I'm going to take those coordinates in red and move them up 3. So up 3, up 3, up 3, and I forgot my scale. So that wasn't correct. I accidentally moved up 6 there, but my y-axis is in 2s. So what I had done is I went like this because in counting it looks like 1, 2, 3, but my scale of 2 makes that a distance of 6. So I should be going 2 and then halfway for 3. 2 and halfway for 3. 2 and halfway for 3. We actually end up on our original coordinate there. 2 and halfway for 3. So with that we get our final function here in green. And with that on your homework and when you're drawing these graphs, if you need to draw these little sketches in between, that's totally fine. Just make sure the final graph is clear. You could use kind of like a heavy marker or something like that to show that that's our final graph. In fact, I could even, I don't know about that far, but making this really clear that this is our end graph. We just need to kind of do this work in between to see where we end up.